Hello students, let us see what are symmetry elements and symmetry operations. You must be aware what is symmetry, right? Just try to imagine a butterfly in front of you. It is exactly symmetrical, yes or no? Now, what is symmetry element then in case of molecules within chemistry? So, symmetry element could be considered in the form of a line, in the form of a plane, or in the form of a point, right? Now, after that, what do you mean by symmetry operation then? See, symmetry operation is the one whenever through the symmetry elements which were specified, अगर इसके थ्रू आप अपने ऑब्जेक्ट या अपने मॉलिक्यूल के ऊपर किसी भी तरह का ऑपरेशन परफॉर्म कर रहे हो, से फॉर एग्जांपल यू आर परफॉर्मिंग अ रोटेशन और यू आर परफॉर्मिंग अ रिफ्लेक्शन, वॉट एवर द ऑपरेशन इज, if after performing that operation through the specified symmetry element, if your molecule's configuration remains unchanged, means the image presented by that molecule looks same as that of the original configuration, then we would say that particular symmetry operation is present within the molecule. Is it clear? That's about your symmetry elements and symmetry operations. Now, one more point I would like to specify here is, see, basically there are two types of symmetries. One symmetry is called as a point symmetry and the other symmetry is called as the space symmetry. Just try to understand what is the difference between both of them. However, in your portion, you are just going to consider the details about the point symmetry. See, what is point symmetry is, whenever you perform any symmetry operation on your molecule, there would be at least a single point within the molecule which is not at all affected by any of the operation, right? Then such symmetry would be called as a point symmetry. But if you consider the translational motion of the molecule, right, then in that case the symmetry associated with the molecule would be called as the space symmetry. Okay? So, in our case, point symmetry is of relevance. So, let us move ahead now. This is a table here to make you understand how many symmetry elements are possible and the associated symmetry operations along with the symbols. So, the first symmetry element is identity, the associated operation is identity, it is given by E. Next one is the symmetry plane, plane of symmetry. The operation is, you have to perform reflection through the symmetrical plane within the plane, right? You will be performing the reflection and the symbol is sigma. Next is the inversion center. So, the operation associated here is, you have to look out for the inversion of all the atoms through the center of the symmetry or through the center of the molecule, you can say, okay? And the symbol is I there. In some cases, it is also designated as CI, one and the same thing. Then, next one is the proper axis. Proper axis means the operation which you are going to perform here is, you have to rotate the molecule through an axis by an angle of 360 upon n degrees. Okay? So, designated as Cn. And then the improper axis, here there are two operations which have been performed one after the another. First, you will be performing rotation. So, you will be rotating your molecule by an angle of 360 upon n degrees, followed by reflection in a plane which is perpendicular to the rotational axis. Okay? And the symbol is Sn. Let us see the symmetry elements and the operations associated with it one by one now. The first one is the identity, E. So, it is the simplest symmetry operation. This is a symmetry operation which does not has any effect on your molecule. So, your molecule's configuration is completely unchanged, it will remain as such. Okay? So, that is your identity. Just for an example, you can take this particular case, CHBrClF. If you look at this molecule, you can understand there is no symmetry operation or any kind of symmetry element associated with this particular operation as such. Okay? Such molecules are termed as asymmetric molecules. or you can say any molecule which only has a single element within it, that is identity, the molecules would be asymmetric in nature. That means this would be necessarily chiral in nature. So it has a chiral carbon atom, you can observe there. Okay, so this is an asymmetric one having a chiral carbon atom, and it is having only one symmetry element associated with it, that is identity E. The next one is about the rotational axis, the proper axis. So as we have already said, proper axis of rotation is designated as Cn. Okay, and what does the Cn means? It means it is an n-fold rotation axis which through which you will be rotating your molecule by an angle of 360 degree divided by n. Okay, either you can say 360 by n degrees, or I can write it down similarly as 2 pi upon n degree, one and the same thing, right? So you can say that way. So what is Cn axis? It's an n-fold rotation which denotes a rotation particularly, and we have to rotate the molecule through an angle of this particular value, that is 360 upon n degree. And whenever you perform this operation, what you are going to observe, the final image of the molecule would be indistinguishable from the original. Just look here. Let us take an example of water. In case of water, I am taking here C2 axis. Okay, so I am just considering a axis, the proper axis which is bisecting the oxygen atom within the center, and now I am rotating it through 180 degree. See why I am saying this is a C2 axis, because this means n. Now already I have said you angle kitna rakhna hai apne, 360 upon n. So n is equal to 2 in this case, so that becomes 360 upon 2, that means it is 180 degree. So I will be rotating my molecule through 180 degree. Okay, so you can see that this particular axis is a C2 axis whereby I am rotating it by 180 degree. And what will you observe? Say for example, say this is H1 and this is H2. So when I rotate it by 180 degree, hydrogen 2 will come on the left hand side and hydrogen 1 will move on the right hand side, right? But however, if you look at the image as such, this is just for your understanding that 1 has moved to 2 and 2 has moved to the one side. But if you look at that overall image of the molecule, you can observe there it is indistinguishable from the original configuration, right? So I can say C2 proper axis of rotation do exist within water molecule. Now let's take another example to make it more clear. HOD. Similarly, as I have done in the water case, similarly I am taking an axis which is bisecting the oxygen atom, and let us again rotate it through 180 degree. That means it is also a C2 axis. So what are you going to observe there? D will come and shift here, and hydrogen is going to move here after rotating it by 180 degree. You can observe there as written on the lower side there. Okay, so D is on the left hand side, hydrogen is on the right hand side. That means, can you say now that your image is having the same configuration as the original one? Definitely not. So I can say in case of HOD type of molecule, no C2 rotational axis is possible. Taken another case. This is an example for ammonia molecule. Ammonia, what is the geometry of ammonia? It is a trigonal pyramidal molecule, right? So in this particular case, it has a C3 rotational axis which is exactly running through the center of the non-bonding orbital, that is, it is running through the center of the nitrogen atom, right? And if you rotate this axis which is crossing through the nitrogen atom by 120 degree, you will find that you are getting the same image as that of the original one. Okay, so it has an C3 axis. Let us try to find it out. See in the figure here. So say for instance, this is H1, this is H2, this is H3. When I am rotating, when I am crossing a C3 axis, okay, how we are going to imagine this C3 axis? It is crossing through a nitrogen atom. So just try to imagine an axis which is perpendicular to this plane of the paper, to the plane of the board there, right, and crossing through the nitrogen atom. Now you just rotate it. You rotate it clockwise through the center by 120 degree, because C3 का मतलब क्या हुआ, it is 360/3, so it is 120 degree. तो अब 120 डिग्री से अगर आप इसे आप रोटेट करते हो, what would you observe now? This one would shift here, okay, then 2 would be shifting here and 3 would come here, okay. Again rotate it second times, again same way, C3 एक्सिस से आप फिर से इसे रोटेट कर रहे हो from the center here, तो क्या मिलेगा आपको फिर से? So your 1 would be here now, 2 would be here and 3 would be here, okay. So what you can observe, every time you are rotating it through C3 orientation or C3 operation you are performing on your ammonia molecule, you are getting an image which is indistinguishable from the original, right. And so you can say in case of ammonia, C3 proper axis exists. Now this particular thing has been given to you to make you understand there is an operation which is also termed as C3-2. Such operations are also been considered and these are possible within various molecules. So when I say C3-2, it means I am performing C3 2 times. So this is C3-1, it could be written this way also, C3-1 or simply as C3, and when I am performing the C3 operation second time and I am getting this final configuration here, right. So this overall configuration would be termed as, you can say you are getting this overall configuration when you are performing C3-2, okay. So C3-2 is nothing but C3 operation has been executed 2 times, that's it. Check the next example, it's a case of benzene. In case of benzene, there are 2 symmetry elements in terms of proper axis associated with it. One is C6 and the other is C2, okay. Let us try to find out this. C6 axis कैसे cross pass होएगी यहाँ से? So you have to imagine the benzene molecule within a plane, right, and just imagine an axis perpendicular to this plane, okay, exactly perpendicular to this plane or exactly perpendicular to this board, and you are moving it clockwise. That axis has been rotated clockwise by an angle of what? Let us find out. So this is 360/6, it becomes 60 degree. So you are rotating it by 60 degree once. What would happen then? In that case, suppose this is 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. So when you are rotating it by C6 axis, rotating by 60 degree, what is going to happen? This would shift here. So this would be now 1, right? 2 would be moving here, 3 would be moving here, 4 would be moving here, this is 5 and this is 6, right? But what about the final image? You are getting the final image at the same way as that of the original. So I can say in benzene C6 axis exists, right? Now let us find out C2 axis कैसे exist कर रही है इसमें. See, there are basically 6 C2 axes possible within this particular benzene molecule. So as been shown here, this is one C2 axis. So when you rotate this particular axis by 180 degree, you will observe that you are getting the identical configuration back, okay. So that's a possible operation there. This is the second C2 axis, this is the third C2 axis. Similarly, see on the lower side, this is the fourth C2 axis, which is basically bisecting the 2 carbon atoms there, this carbon atom and this carbon atom, right. Similarly, this is the fifth C2 axis and this one is the sixth C2 axis. Is it right? So that's about this particular proper rotation, the proper axis of rotation and the identity element. The next details I'll be explaining you within the next video. Thank you.